Thus far, we have considered addition, subtraction, multiplication, and division of fractions, vulgar fractions especially. But think about it. Is it possible to have a case of number operations in fractions containing more than one of these four basic operations? Is it possible to have a case that contains addition and subtraction in one, multiplication and addition in one, just a combination of some or all of these basic operations in one operation? That takes us to lesson objective number 9, and that is mixed operations in fractions. Please listen so attentively as I develop this section. In this section, let us learn mixed operations in fraction. Before now, that is in the previous sections, we learned separately in each section how to add, subtract, multiply, and divide fractions. In this section, we are concerned with a single problem in arithmetic of fractions, which contains more than just addition, just subtraction, just multiplication, or division. Instead, a combination of some or all of these operations. Please notice what has happened in this number operation. It contains addition, division, subtraction, multiplication, and even more, all in one number operation. The question is, how do we solve this type of problem? We have learned how to add, we have learned how to divide, we've learned how to subtract and multiply. Which of these operations should therefore be taken first? That is, should I start adding? Should I start dividing? Should I start carrying out subtraction or multiplication, so that the process of condensing this number operation to a finished simple form will be successful? Again, I ask, which of the four basic number operations should I start with? Anyway, this was a problem in the past, and today we have a conventional method, a conventional formula for solving problems in arithmetics involving more than one basic number operations. Please watch out as I write the conventional method of solving problems of this kind, a kind of problem in arithmetic in which we have more than one number operation. Please see the method, see the formula. And here comes the formula for solving mixed operations in arithmetic, fractions included. It is BODMAS. It appears to be a word, but in actual sense, it is an abbreviation, an acronym. This was developed by convention. What does B refer to? B simply tells us that we should start solving such mixed operations in fractions and all kinds of arithmetic by checking if there is a bracket in the operation. If it contains a bracket, solve it first. Therefore, B means bracket. Next is O. The O tells us that if we check for bracket and we find it in the number operation after handling bracket, the next is off. But if there is no bracket, then the first should be off if it is there. This BODMAS is an acronym that tells us, that directs us as to which number operation we should carry out first. It does not mean that you should insist that B must be in that number operation. It simply means if B is in that operation, do it first. If of is in that operation, it is what comes after bracket. D stands for division. If that operation contains division, it is what comes after of. M is for multiplication. If that operation contains multiplication, it should be done after division. Next is A, that is addition. It tells us that if there is need to carry out addition, it should be done after we have done all of this, if they exist. That is after we have done multiplication, division, of, and bracket. The last is S, standing for subtraction. It thinks after we have done these other ones coming after it, if they exist, the next and the last is subtraction. Therefore, this is an acronym giving us the order of precedence when it comes to choosing a particular number operation to carry out when carrying out operations called mixed operations. Now, let us apply this BODMAS in solving this only example which I choose to present here. After this single example, I believe that any other thing I ask you to do with BODMAS, you can, because this example was crafted to ensure that it contains all the necessary instructions that will make it possible to use each of these letters in this acronym. None is missing. For instance, B, that is bracket, we have it here. O, that is of, see it here. D, that is division, see division here. M, that is multiplication, see it here. A, that is addition, see it here. And last is subtraction. We have it here and we have it here. But this is a part of brackets, so we don't consider it at this point. Instead, it is this that is for this subtraction. It doesn't mean that each time you have a problem to solve that is involving mixed operations in fractions, that all of this must be carried out. I said earlier, it is some or all of them that you will see. Now, join me as I apply BODMAS in evaluating this number operation. First, we start with this bracket. So we're going to use the knowledge of subtraction to condense these two fractions to one and then join the rest. Please, let us handle the bracket first. Let it happen. And here it comes. We focus on this bracket alone, while the rest remain the same. Notice what has happened to this bracket. This bracket has become what it is here. I hope you know why this became this. If you have forgotten, please refer back to subtraction of fractions and addition of fractions. Both of them possess one formula called product formula for evaluation. It is that formula I applied here. That is this times this minus this times this over this times this. Recall. So 2 times this 4 is 8 minus 3 times 1, see it here, minus 3 over 3 times 4, that is this 12. In that case, it has become 8 minus 3 over 12, while the rest remain what they had been earlier. See them here. 1 over 3 is still there, 3 over 8 is still there. Just one thing has changed, and that is this one. The next line treats this 8 minus 3 over 12 further. That gave us this 5 over 12. I hope you know why. 8 minus 3 is this 5, then over this 12. All others remain the same. Then out of this bracket, we now have this 12. Off is still where it is. 3 over 5 is still where it is. 1 over 3 is still where it is. 3 over 8 is still where it is. Now at this point, we have dealt with this bracket. Next is this off. What is off? Off is here. That means that I will now join these two because it is these two that are connected by this off. Off, essentially, when translated, means multiplication. Anyway, the history of how off became multiplication is not why this thing is being presented. But just know it at this point that after being interpreted, off also means multiplication. Therefore, I will join these two again. All right, please follow me as I join this 5 over 12 and 5 over 3 by multiplication using this off as multiplication. Please watch out. Now, see how this off has been treated. This is 5 over 12 of 3 over 5. So, like I said earlier, off has been handled as multiplication. Consequently, we remember how to multiply fractions. 5 times 3, 15. 12 times 5, 60. So that in the end, all others remain the same, except that these two, when combined, have given us this fraction. Now, 15 over 60 is not in its lowest term. Nothing is wrong with continuing in the form it is, but it is less difficult to convert this 15 over 60 to its lowest term, and that is what has happened here. Other fractions maintain their structure and position and value, but this has changed its appearance from 15 over 60 to 1 over 4. The value is the same position, but the actual magnitudes of numerator and denominator have changed. The rest maintain everything, their position, the magnitudes, and then their values. But this has changed in magnitudes of the numerator and denominator. So far, this is still where it is, this is still where it is, this has become this has become this, and this is still where it is. I hope what is going on here is clear to you. So at this point, what do you think should happen next? We go back to the BODMAS. We've done B and O. That is, we have treated the bracket and off. Next is division. Is there any place that is division here? Sure. This is where we have division. This takes us to combining these two to become one fraction. Please follow me as I combine 1 over 2 and 1 over 4 in division. Now, notice that these two have become just one thing. 1 over 2 divided by 1 over 4 is equal to 4 over 2. I hope you remember what has happened here, or you remember what led to this 2 becoming this. Surely, because you have been taught earlier, and I believe you learned how to carry out division with fractions. Recall that to divide is just AD over BC instead. So in the end, 1 times 4, 4 over 2 times 1 is 2. So in the end, this 2 over 5 is still where it is. But these two now have become 4 over 2. Next, 1 over 3 is still where it is. 3 over 8 is still where it is. At this point, 4 over 2 has to become something simpler. Let us keep carrying out number operations until all these numbers, all these fractions condense to one fraction. Please, let's continue. Here, we bring forward the last thing we saw. and that was 2 over 5 plus 4 over 2 times 1 over 3 minus 3 over 8. I hope you recall. Okay, so next, this 4 over 2 is equal to 2. That is what brought this next line into being. 2 over 5 is still where it is, but this has become 2. 1 over 3 is still where it is, and then 3 over 8 is still where it is. But this 2 has to be rewritten to take the structure of a fraction, though not a fraction. Again, we put 1 as its divisor so that it takes the structure of fractions, though it is not actually a fraction. So to facilitate the process, this 1 has been put here. Next, we get back to BODMAS. We are through with division. That led us to 2 over 1. After this division comes multiplication, and that takes us to these 2. We condense these 2 to become one fraction. 2 over 1 times 1 over 3. Again, follow me as I condense these 2 fractions to one fraction by means of multiplication. Let it happen. And here it comes. Recall how to multiply fractions. This times this over this times this. I just hope you remember. That takes us to what we have here. 2 over 3 is still where it is. But these 2 have combined to form this. 3 over 8 is still where it is. We now have 3 fractions remaining. What is next? We go back to the BODMAS. We have done bracket, we've done off, we've done division, and now we've done multiplication. What remains? It is this addition. Let addition take place, which means that these 2 should be combined first, and last 3 over 8 taken from the result. Please follow me again as I combine 2 over 5 and 2 over 3 to yield a single result. Now notice what has happened. These 2 have combined to form this. That is this. How? Recall how to add fractions. This times this plus this times this over this times this. This times this is 6 plus 5 times 2 is 10. Please, I am not multiplying the 2 fractions. Instead, I'm dividing, and I'm carrying out addition. And in that addition, we recall that we multiply. That is what I'm doing right now. So again, I said 2 times 3 is 6 plus 5 times 2, 10 over 5 times 3, that is 15. So we now have 6 plus 10 over 15. And that takes us to this 16 over 15. Then minus 3 over 8 is still where it is. So the whole thing has led us to 16 over 15 minus 3 over 8. So if we carry out this last operation, which is subtraction according to BODMAS, the last answer for that complicated operations in mathematics, mixed operations in mathematics or fractions, will be yielded or will yield. Now please follow me as I take on this last operation of subtraction. And now this has become this. That is this times this. I'm trying to carry out subtraction between these 2 fractions. With that formula you have learned earlier, you will notice that we multiply while adding or subtracting. So that is why I'm saying 16 times this 8 is 128 minus 15 times 3 is 45. Then over 15 times 8 is 120. So we now have 128 minus 45 all over this 120. Notice what happens next. And here is the answer. It is equal to 83 over 120. Why? 128 minus 45 is equal to 83 over this 120. The summary, therefore, is what follows. And here comes the summary of the entire process. That is, this complicated operation has led to this answer. The answer is 83 over 120. The exercise was so long but quite interesting. At this point, let me remind you that I said that this is the only example that I will use to practice how to carry out mixed operations in fractions. I believe that what has happened here has been so clear that when given anything similar, you can follow the same pattern or even improve on it to get the correct answer. Now, it is time for you to check whether you can carry out mixed operations in fractions. Please, watch out for an exercise. And here is a checkpoint. It says, using BODMAS, evaluate the following operations. Number 1, 3 over 8 divided by 2 over 5 minus 1 over 6. Number 2, 5 over 6 minus 1 over 5 times 2 over 3 plus 1 over 6. Number 3, 1 over 2 of 2 over 5 minus 1 over 7 times 2 over 3 plus 4 over 5. Number 4, 3 over 4 minus 2 over 5 times, then in bracket, 1 over 2 plus 1 over 3 divided by 3 over 8 of 1 over 5.